Hello, everyone. This is our next lesson on secants. So, this is kind of the point in the chapter where things are going to kind of all look the same, and it's going to be kind of hard to keep everything straight, okay? So, take good notes, try to pay attention, and we will work through it together. But we are going to use properties of secants and tangents to find missing angle measures. Okay, so our first little property we have here. First, we need to probably talk about a secant line. So think, a tangent line is a line that touches your circle in one spot like this. So this would be a tangent line. It has one point of tangency, right? Okay, that was last lesson. This lesson, a secant line is a line that goes through your circle and touches it in two spots. It intersects in two places. It's a secant line, okay? So that is a secant line. But if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of their intersected arcs. Whoa, a lot there. So let's break it down. So if we're looking for angle 1 right here, so if I trace out angle 1, we all see this, right? I can find that angle measure by taking the sum, which means to add. So if I add arc AD plus arc BC and then divide it by 2, that gives me the measure of angle 1. So I take its intersected arc, so arc AD and BC, add them together, then divide by 2, and that will give me the measure of angle 1. Just like if I wanted to find the measure of angle 2, here we go, let's find those intercepted arcs. My first arc would be AB, my second arc would be DC, add them together, divide by 2, and that will give me my angle measure. So again, kind of like the other lessons in this chapter, the math itself isn't hard. You guys can add and then divide by 2. That's not the difficult part. The difficult part is remembering when to do these things, right? Because everything kind of blends together and looks the same. So let's hit it home with some examples here. We are looking for the measure of angle AED. This little guy right here, right? So remember, you're going to take your intercepted arc, so 45 and 109. Add them together, and then divide by 2. If we add them together, we get 154. Divide that by 2, and we should get 77 degrees. And that's it. So again, like I just said, the math itself, not too hard. It's just calculator work. Try another one here, angle STR. So that's the angle we're looking for. Trace out your intercepted arcs. 86, 112. So 186 plus 112 divided by 2. Add them together, we should get 298. And then we should get 149. One more practicing this idea here. Oh, this one's fun. This time we're looking for the arc. You guys see that? I'm not looking for an angle. We're looking for this arc right here. Okay, so we do kind of the same little process we have. Here's our angle. Here's my other intercepted arc. So let's just write it out how we would normally do it. Take your intercepted arc, so 74 plus x, because we don't know what it is, we're looking for it, divided by 2, and set it equal to 62. Okay, how do we undo divide by 2? Simply multiply by 2. Drop down your 74 plus x. 62 times 2 is 124. Subtract over that 74, and we find that our arc is 50 degrees. Woo! Okay, let's try another situation, another scenario that could happen to you. What happens if you have a secant and a tangent line that intersect at the point of tangency? then the measure of each angle formed is equal to half the measure of its intercepted arc. So let's just kind of make sure we're all on the same page here. Here's our secant line, right? It touches your circle in two spots, at B and A. Here's your tangent line. It touches your circle in one place, at A. And when this happens, if you wanted to find the measure of angle 1 here, I wanted to find the measure of angle 1, you take half the arc measure. So angle 1, right, formed right here, take half of its intercepted arc. So half of AB would give you the measure of angle 1. Just like if you want to find the measure of angle 2, so I trace out angle 2 right here, you take half of its intercepted arc, which would be BCA. This time you're just taking half. So try a few examples with these. We are looking for angle DEG. We're looking for this angle measure. Trace out your intercepted arc. And we are told your intercepted arc is 308. So simply just take 308 divided by 2 and we get 154. Done. Done diddle. Next one. Find the measure of angle DBC. DBC, this is what we're looking for. Well, shoot, you guys. When I trace out my intercepted arc, I get nothing. We have no information. This problem's impossible. Well, you guys are smart enough. You know that's not true because we know that this arc here is 192. So what's left over of our 360? It's 168. So now that we have our intercepted arc of 168, divide that by 2, we find that our angle measure is 84 degrees. Woohoo! Okay, let's go to the back of our notes because now we have some examples when we have some exterior intersections. So now we'll have our secants and tangents intersecting outside on the exterior of our circle, okay? So we have a few different scenarios when this happens, but what you need to remember is the measure of the angle formed is equal to half the difference of your intercepted arcs. So when it's on the inside, it's the half of the sum of your differences, and when it happens on the outside, it's half the difference. I think I might just mess that up. Shoot, you guys. What did I say? If it happens on the inside, you take the sum of your intercepted arcs, divide by 2. When it's on the outside, you take the difference and then divide by 2. I probably just confused you more there. I apologize. Okay, if you have two secants, so do you guys see how here's a secant line? It touches your circle twice. Here is your other secant. So if you're looking for the measure of angle A, you take arc CE, subtract it from BD, then divide by 2. So we're taking your big arc minus your smaller arc and then dividing by 2. You could have a secant line like this guy here that touches a tangent line, so it only touches your circle once, but the process is the same. You're going to take your intercepted arc, so BD, subtract BC, then divide by 2, and that will give you the measure of angle A. And then finally, you could have two tangent lines, so that it touches your circle in this one place, like so. And same thing, take BC, subtract your other intercepted arc, divide by 2, and you will get your angle measure. Again, a lot of information here, you guys. I know I'm really not a fan of like algebraic formulas. I think they confuse you more than just actually doing the problem, but get that down and we will try some examples to hit it home. So, measure of angle KLM. We're looking for this guy. So this is an example of two secants, right? Not that it matters, but if you like want to put that down, that's cool. if you want to look at your top examples. So we have two secants. So what do? We take our arc 140, subtract our little arc of 66, then divide by 2. So 140 minus 66 is 74. Divided by 2, we get 37 degrees. Next example, we have a tangent line and a secant line. So I'll put that one tangent, one secant. And we're looking for the measurement angle ABC. So same old story, you guys. Ooh, they're making us work a little bit harder here. What is our big arc? They didn't tell us that. Those punks. We gotta figure it out. So let's figure out what's left of our 360. So 360 minus 62 minus 88 gives us 210. All right, so now we take our big arc of 210, subtract 62, then divide by 2. 210 subtract 62 is 148. Divide that by 2 and we get 74. And then finally, folks, our last example here. If we look and notice, we have two tangent lines. Process is the same. It's just nice to identify those things. And we are looking for the measurement angle PQR. So, yikes. We need to find out what that little archeo mark is. So 360 minus 313 gives us 47. All right, now we're in business. We got everything we need. 313 minus 47 divided by 2. 313 minus 47 is 266. Divided by 2, and we should get 133. All right. We will do more examples together in class. Thank you for watching this video lesson. You guys are the real heroes. Talk to you later. Goodbye.